In this video we're going to look at some further trigonometric equations and identities. In the last video you will have met the sec, cosec and cot functions. So sec theta is 1 over cos theta, cosec theta is 1 over sin theta, and cot theta is 1 over tan theta. If we're dealing with simple equations involving these functions, then it's usually best simply to go back to their definition and then solve the equations in terms of cosine, sine or tan. So for example, if we have to solve the equation cosec 2 theta equals 3 for angles theta measured in degrees between 0 and 360 degrees, then we'd start off by saying that cosec 2 theta equals 3 means that 1 over sine 2 theta must equal 3. In other words, sine 2 theta must equal 1/3. To solve this equation, it would be sensible to make a little substitution. So if we let z equal 2 theta, we've got now the equation sine z equals 1/3. The smallest value of theta I'm allowed is 0. So the smallest value of z is 2 times 0, which is 0. The largest value of theta that I'm allowed is 360 degrees. So the largest value of z that I'm allowed is 720 degrees. To solve the z equation here, we can use our calculator to get a first solution. So we've got z equals sine to the minus 1 of 1/3, which gives me 19.47 degrees. Then it's worthwhile just having a mental sketch, or actually a physical sketch, of the sine curve between 0 and 360, and also to remember that the sine curve repeats every 360 degrees. So the fact that I've got my first solution is 19.47 degrees, the symmetry of the curve tells me that I'm going to have another solution, z2, at 180 minus 19.47, which gives me 160.53 degrees. And then the fact that the sine graph repeats every 360 degrees tells me I'm going to have a third solution, which is 19.47 plus 360, and a fourth solution, which is going to be 160.53 plus 360. There won't be any more solutions because the next one on would be 720 plus the 19.47, and that's outside my domain of values for z, which are z lies between 0 and 720. We know that z is 2 theta, so theta must be a half z. So the possible values of theta are 9.7 degrees, 80.3 degrees, 189.7 degrees, or 260.3 degrees. Now from Unit 1 of our maths studies, we've come across the identities that cos squared theta plus sin squared theta is always equal to 1, and that tan theta is always equal to sin theta divided by cos theta. Recently, we've introduced the definitions of sec, cosec theta and cot theta. If we now look at equation 5 together with equation 2 that we've got here, then we obtain cot theta equals 1 divided by tan theta, or cot theta equals 1 divided by sin theta over cos theta. Dividing by a fraction, we simply turn the fraction upside down and multiply. So we've got cot theta is the same thing as 1 times cos theta over sin theta. In other words, we've got cot theta equals cos theta divided by sin theta. We're going to call that identity 6 in our little list of identities. We know that cos squared theta plus sin squared theta is always equal to 1. If we divide through by cos squared theta, I obtain 1 plus sin squared theta over cos squared theta is 1 over cos squared theta. In other words, I obtain 1 plus sin theta over cos theta all squared equals 1 over cos theta squared. Sin theta over cos theta is tan theta. That's equation 2. 1 over cos theta is sec theta, which is equation 3. So making use of equations 2 and 3, I obtain 1 plus tan squared theta must equal sec squared theta. Returning to equation 1 again, but this time dividing through by sine squared theta, will give me cos squared theta divided by sine squared theta plus 1 equals 1 over sine squared theta. In other words, I've got cos theta over sine theta all squared added to 1 must equal 1 over sine theta all squared. And now, making use of identities 6 and 4, I've got cot squared theta plus 1 must equal cosec squared theta. These 8 identities that we've just obtained are going to be really useful in the remainder of this video. So for example 2, we've got to solve the equation 4 sec theta equals 1 minus 3 tan squared theta for values of theta that lie between 0 and 2 pi, which means that we must be working in radians. Using equation 7, I know that tan squared theta is the same thing as sec squared theta minus 1, which means that I can rewrite the equation that I've got as 4 sec theta equals 1 minus 3 lots of sec squared theta minus 1. In other words, I've got 4 sec theta equals 4, take away 3 sec squared theta, or 3 sec squared theta plus 4 sec theta minus 4 equals 0. So I've got a quadratic equation in sec theta, which I can solve either by factorising or by using my calculator to obtain the possible values of sec theta. Either way, I get sec theta equals minus 2 or 2/3. We know that sec theta is 1 over cos theta, so that tells me that cos theta is either minus a half or 1.5. We know that cos theta can only take values between minus 1 and 1. It certainly cannot be 1.5, so we can delete that possibility straight away. So we know that cos theta has got to equal minus a half. If I use my calculator first of all, cos theta equals minus a half gives me theta as cos to the minus 1 of minus a half, which is 2 pi by 3. Remember, I'll have to be working in radians to get this coming out exactly. Using the fact that the cosine graph is symmetrical about the line theta equals pi, means that the other solution is going to be at theta equals 4 pi by 3. So the solutions of my equation that I started with are theta equals 2 pi by 3 and theta equals 4 pi by 3. Moving on to another example, we've got to solve the equation cot theta equals minus 5 cos theta for angles theta which are in degrees and between 0 and 360. So if we go back to our little list of equations, we know that cot theta is the same thing as cos theta divided by sine theta. So I can rewrite the equation as cos theta over sine theta equals minus 5 cos theta. Multiply up by sine theta to clear the fractions. We've got cos theta equals minus 5 cos theta sine theta. Now it's really important at this stage that we remember that we mustn't cancel through by cos theta, because cos theta might itself be 0. So what we must do instead is we must create a 0 on one side of the equation and then factorise through by the common factor. Pushing everything onto the left hand side, we've got cos theta plus 5 cos theta sine theta must equal 0. implies that we've got cos theta times by 1 plus 5 sine theta equals 0. That's our factorisation stage, which means that either cos theta equals 0 or sine theta equals minus 1/5. Cos theta equals 0 gives me theta equals 90 or 270 degrees. Sine theta equals minus 1/5. Using a calculator to obtain one solution of the equation of sine theta equals minus 1/5 gives us theta equals minus 11.5 degrees. Now that isn't in our domain because we're only interested in values between 0 and 360. But the symmetry of the sine graph tells me that I'm going to have a solution at 180 plus 11.5 degrees and a solution at 360 minus 11.5 degrees. So I've got solution at 191.5 degrees together with a solution at 348.5 degrees. So the solution of my full equation is theta equals 90, 270, 191.5 or 348.5 degrees. For our final example, we're told that the angle alpha is obtuse with cot alpha equals minus 9. We've got to determine the exact values of sine alpha and cos alpha. We've got, using equation 8, we know that cosec squared alpha is going to be the same thing as cot squared alpha plus 1. Cot alpha is minus 9, so cot squared alpha is 81. So we've got cosec squared alpha is going to be 82, which means that cosec alpha must be plus or minus root of 82. We know that cosec alpha is 1 over sine alpha. So I've got 1 over sine alpha equals plus or minus root of 82. So sine alpha is plus or minus 1 over root 82. The angle alpha is obtuse, which means that it's between 90 degrees and 180 degrees if we're working in degrees, or it's between pi by 2 and pi if we're working in radians. But in whichever case, the sine of an obtuse angle is positive. So we can say that sine alpha is 1 over root 82. We know that sine squared alpha plus cos squared alpha is always equal to 1. So cos squared alpha is 1 minus sine squared alpha, which is going to be 1 minus 1 over 82. So cos squared alpha is going to be 81 over 82. So cos alpha is going to be plus or minus the square root of 81 over 82. Square root of 81 is clearly 9. Square root of 82 I'm not going to do very much with. So I know that cos alpha is plus or minus 9 over root 82. But we know that alpha is an obtuse angle and that the cosine of an obtuse angle is always negative. So we've got cos alpha must be minus 9 divided by root 82. What you might like to do is see whether you can devise a second solution to this example that starts, instead of using formula 8, but using formula 5 and formula 7 instead, to first of all determine the value of cos alpha and then deduce the value of sine alpha. That concludes our video on further trigonometric equations and identities.